Here in this fourth lesson on structural geology, we're going to talk about joints and veins. It'll be kind of an introduction to morphology and terminology. And this is a brittle deformation type. And of course you remember joints are natural fractures along which no shear displacement has taken place. So the rock breaks but does not move relative to each other along the fracture plane that develops. And veins, of course, are filled with mineral precipitate from water solution as water travels through these fracture areas. And we're going to talk about the morphology and the things that you're going to see in relation to joints and joint characteristics. But it's important to keep in mind that the interpretations of exactly how these form and exactly why and under what circumstances are kind of up for grabs. There's a lot of debate in the field about it. So this is something we want to keep our minds open about, because even though we can talk about a lot of details, there are no absolute answers yet. So I think a helpful way to start this conversation is to talk about plumose structures. This is a structure you often see in association with jointing. It's something that occurs on the fracture planes or fracture faces of joints, and it represents the propagation of stress along the joint as it forms. So this is, like we said, joints are formed by tensile stress, which is a mode 1 loading. And we talked about mode 2 and mode 3 are our two modes of shear loading. And these structures, the reason why they form these plumose structures is because no rock is completely homogeneous, and the forces on it are not isotropic. Remember, we said the same in